Good evening. We're back for another edition of Meteorology Lab from the Dallas-Fort Worth area here. And we had some really bad storms last night. We actually took a lightning strike here, and fortunately I made it out okay, but I'll show you one of the casualties here. The DSL modem had a strike about 100 feet away on one of the power lines, and fortunately I keep some DSL modems around here, some spares, because they're only like $25, and that's certainly a good idea if you don't want to get stuck without internet at 4 in the morning. Anyway, let's see here. Let me get this out of the way. I was doing some file uploads earlier. Checking the storm reports, I didn't see any particularly big hail. There was a comment in here about 4-inch hail, and I was looking for that, but I didn't really see it. But here's the distribution of the hail, mostly over North Texas last night, and then for today, mostly confined to around the Austin area, but we got a couple of big storms around the Del Rio area. Let me switch over to the radar, and we can check that out here. This is the Brownsville radar in South Texas, and we have a pretty strong multi-cell right around the Eagle Pass area. So we can zoom in on that and take a look. Definitely got some reflectivity gradients in that thing. The core of the storm is a little bit to the center, though, so, especially right here. See, we're comparing the large extent of the cell itself, and then we're comparing the core, and the closer that is to the center, the more in the non-severe range that's going to be. Now, another thing that we can do to evaluate the storm is go to higher tilts and look for overhang. Don't see a whole lot of that. Here's the storm top, and I'll put a dot on that. Sitting about right over the core there, so it's probably in the strong range, but I wouldn't call that severe. And then the tops on that, see, we're picking up a few specks at 67,000 feet. I would probably call that 55. That's probably getting up to about 58 to 60,000 feet on that storm. But a very high tropopause there. And then this other one to the north, that's on the order of about maybe 50,000 there. Now, one other way we can see the storm tops is on the GOES 16 imagery. And there's a look at that, and thanks again to Couchelman Vetter in Germany for setting this up. It's one of the only GOES 16 sources I know of, but you can see 1 hour of animation here, and lots of storm tops, like right here. This is the one we were looking at on radar right there, and all the way down in Mexico. So storm activity definitely underway there. So what's causing all the storm activity? Let's look at the 250 millibar chart. Well, we got some strong flow. Monterey right there in Mexico reporting 50 knots at 250 millibars. 55 there at Del Rio, so that's going to support some organization of the cells and some longevity. Got a little bit of troughing in here too. Then at 500 we see that there's 20 knot flow over that area, a little bit weaker there, so we like to see that a little bit stronger to get into the severe range. Polar front jet over the northern plains from about Oregon through the Great Lakes. And we've lost that deep troughing over the western U.S. A couple troughs over the U.S., one over the Midwest, and the other off the Pacific coast. And as we know, if we take a major shortwave trough and a up or downstream ridge, and then we place the polar front jet, looks like that's actually a little bit further to the south like that, we're going to find the fronts to be kind of like this. So that's our starting location for where the fronts are. Pretty good storm system off the Pacific. Okay, I went ahead and did a restart on the stream. I'm trying to find the optimal bit rate. As you might have noticed, I've switched over from one of the open broadcaster software packages and trying to get the new one up and running. And I see we're pumping out about 600 kilobytes per second. We are on 6 megabit DSL here, which is not particularly fast. Let me switch over to the... I'm looking at the YouTube output page and seeing how things look. And while the stream gets itself worked out, let me take a look here and... Okay, guys, we're back with the old software package, and I'm going to probably have to bring some of the old settings over and convert things. So we should be up and running now. And I'll work with this later tonight. So anyway, let's head on with the chat here. Let me take a look and see who we've got. We've got Andrew and Mike Wan, Fun with Tech, and Greg Kerner, chasing that supercell. Only saw 3/4-inch hail near Eureka. Andrew mentioning the 2-inch hail was southwest of Peoria near Bartonville there. Hello to Ron Chalfant in South California, and Kevin McKinney. Tom J is here. Jeremy Mattingly and Adam Davis. Michael Burrell, Carl Berghoff, Eddie W., Victor Cabot, and Brett Dean. Lightning took out internet. Yeah, it did. 84 degrees in southern Jersey. That's pretty warm there, but big ridge on the east coast there. Greg Schultz, luckily severe weather missed us in Milwaukee. Alexei mentioning the storm is bad last night there in central Texas. Tons of flooding, and garbage can decided to float away and can't be found anywhere. Carl Berghoff saying there was a weak tornado in Wausau, Wisconsin Sunday night. Second one for Wisconsin from Greg Schultz. Fred Reamer checking in up in North Dakota. Eddie Holmes and Brian Harp. Then we see a little discussion about the stream. I guess it was breaking up there towards the end. Greg was wanting to look at the volume mode of the storms. Maybe you can bring that up real quick. And let's see here. Scrolling down the page. Tom J mentioning the College DuPage goes 16. Sue M is here, and let's see here. Scrolling on through. Okay. Stream is solid. Okay, I'm going to run some tests later tonight because I like the other package quite a bit, but as you can see, it's going to take some tweaking to get it working. Okay, here's that convection out in southern Texas, very high tops there, and the worst of it looks like over the Eagle Pass area, and we can see that's moving south there. And one more look at the radar. There's that storm, and we can take a slice through that real quick. So it doesn't have that overhanging appearance. It's got that triangular mountain shape. So when we see that, we're thinking more of non-severe, and it can definitely still put out wind and some hail, but we're unlikely to get rotation developing in something like this. Okay. And then there's a volumetric mode. I haven't used this very much, to tell you the truth, but let me see if I can bring that up real quick. And this uses reflectivity surfaces here. So that's a look at the storm, and we can go into this panel here and change some of the, like this is the lighter precipitation, and of course this has a larger volume, and then we can shrink that down to the higher reflectivities. And this is not really good for using at such distances like this. This is about 100 to 150 miles away from the storm. Well, probably about 100. So you can see a lot of it is being overshot down in the low levels. But anyway, this just kind of shows us the lack of any overhang, and that's our storm in South Texas there. Okay. Thickness and pressure. We can see high pressure covering the Midwest here. A little bit of a thermal gradient across the Great Lakes area. And then out in Texas, we've pushed that front all the way to South Texas, so it's going to be somewhere in this area. And there's the gradient right there, from Texas all the way up to the Dakotas. And then we pick up another gradient out on the west coast, somewhere in here. So maybe we're going to do something like that, and possible warm front up in the Redding, Red Bluff area, Eureka. And then this connects probably with the other front further out west. So these will be coming on shore, and it looks like the track of that from what we saw yesterday is towards the Central Plains. Let's take a look at the soundings. Bring up Fort Worth. We saw a little bit of that cloud material out there. Let me bring that back up. Yeah, so I wanted to discuss the clouds that we're seeing here and what would be the origin of this cloud. And this is what you have to be asking yourself. You have to know where your clouds are coming from to really understand the weather picture. In this case, we have a lot of residual moisture near the ground, and that's being lifted, and we've got kind of an unstable layer in the lowest couple thousand feet of the atmosphere. But we are strongly capped, so there's no vertical. You can see here we don't have like towers or anything like that. So this is some very shallow, vigorous convection that is spreading out beneath that cap there. And just to show you that again, this is that cool air mass here. It's coolest at about 4,000 feet right here. Very strong dry adiabatic lapse right there. And here's that moisture. And some areas of North Texas, they're even more moist. So we get these lifted parcels that are very low to the ground. Very good convection in there, but they hit this cap at about 5,000 feet and they spread out. So there's nothing above that. This is all the overlying air mass, the old warm air mass. And we can see tropopause very high. So this is basically the tropical air mass on top. And taking another look at that, maybe we can go down to Corpus Christi. We know things are more conducive there to deep convection. And we see a lack of a cap there. So we try to throw in a little bit of heating, maybe like 79, 80 degrees. And we get a sounding kind of like that. So probably about 1,500, 2,000 cape. Very deep, all the way up to 43,000 feet or so. And then above that, our overshoots are going into the 50 and 60,000 foot range up at the top there. And we can see the wind flow very weak in the low levels, so not conducive to rotating storms, but if we go up to anvil level, we do find 50, 60, 70 knot winds up there. Okay, for dynamics across the U.S., here we go. 0Z. Ridge building in across Texas right there. The troughing we had last night moving out into Arkansas and Louisiana. And then we have a couple of more troughs moving onshore here, one around the Las Vegas area. And we get into our deep low pressure areas right off the coast. And we'll see that moving on shore gradually later in the week around Thursday or Friday, so rain chances will be going up for Oregon and California. And then the layout of our frontal systems, you can kind of guess that they're going to be something like that. So a frontal system moving through Nevada, Utah, Idaho, and then crossing the Rockies, and that'll be moving up into the Dakotas, taking kind of a northerly track there. Here in Texas, we'll be under the ridge, so kind of a warm weather pattern in this part of the country. And then just a quick look at the 850 millibar chart. Do we see any evidence of that cold front in Texas? Well, we see a little bit of northerly flow here. Don't see much of a temperature gradient out in this area here. So we can go back to the sounding and kind of see what's going on. Where's our 850 millibar level? It's going to be about right there. So it looks like the 850 millibar level is in the warm air mass. So if we want to evaluate the frontal air mass, the cold air mass, we have to find a 925 millibar chart. Now, I don't know where that is on the internet, but my guess is, well, you can do it with digital atmosphere, but my guess is it's going to be at College DuPage. So let's see, College DuPage weather. Then we'll go to analysis data. Upper air maps, and let's see here, we're given 500, 700, 850, kind of limited there. Let me try continental U.S. and see what we're offered. Nope. Only just the standard levels here. See, I've always thought it would be nice to have a website where you can kind of build your own levels. You know, sometimes I want to look at 600 millibars when I'm analyzing the cap. It would be nice to have a little bit more flexibility, but anyway, that's not really a complaint about College DuPage, but that's just something I would like to see more from some of these websites. But what I can do, I can put in 925 millibars into Google, and maybe Ohio State, apparently they've got a chart here. So we always double check when we're on these new sites here. 12th at 0Z. Yep, that's correct. So there you go. Now, it doesn't show temperature here. The shading here looks like it's relative humidity. But if we wanted to, we could do isotherms. So there's 20, there's 18. 16 is going to be like that. And then 14 like that. So now we can kind of see the composition of that cold air mass. Very shallow, working its way from the lower Mississippi Valley. Okay, and there's a quick look at SPC's mesoanalysis. Looks like the leading edge of that cold air mass may be like that, but there is a lot of high pressure building in, and this is actually what's responsible for a lot of that thunderstorm activity. If we go to, let's see, let me find a good chart here. Yeah, here we go. Surface dew point from the NAM model. And yeah, take a look down in Mexico here. You can see a lot of onshore flow here. So pretty good pressure differential between the Gulf of Mexico and the Mexican interior there, bringing moist air upslope into the higher terrain here, orographic lift, and that's what gives us the thunderstorm activity there in the mountains of Mexico right here. Okay, let me just run through the chat real quick. There's a lot of chat, so I'm not going to be able to catch everything in here. Tom J says he is a supporter. Yeah, I need to put a list of supporters in the credits. That's been on my to-do list, and hopefully I'll get that done. But yeah, I appreciate the Patreon donations, and my dream is to bring in symmetric DSL and start pumping out HD video. It would be nice to have that for the severe weather webcast, but I'm not too sure we're going to be able to do that or not. We would have to bring in a pretty good chunk of money here. Jarrell, Texas, F5 formed on a day with no wind shear. Yeah, that's a good point. We did have a front move through on the Jarrell day, slowly sinking southward. Those boundaries, when you have those boundaries there and a little bit of low-level shear, that can be all it takes to get things going. And Chuck Doswell explained violent updraft was a reason. Yeah, so very high cape. That was a super high cape day. I think we were running over 5,000 to 6,000 that day. You know, we can probably take a quick look at that. Let me bring that down here. Let's see here. Take a quick look at the Jarrell situation. Why not, since we don't have anything else going on. Okay. Probably got that misspelled there. Okay, give me just a second. I'm going to pull down that data. That was 1997. I think that was the 29th. Yeah, correct me if that's wrong, but I think that was on the 29th there. And I'm going to pull down the upper air data, and we'll look at that there. And meanwhile, I'm going to fire up Rayob here. Rayob is a very cool upper air analysis program. And with that, we can look at soundings and photographs and all that. And let me get that started up here. Okay. 97. Don't worry, if this takes too long, I'm going to probably do this tomorrow. Okay, hang on. I've got to bring up my connection to that drive. Okay, there we go. Okay, so there's our data, and I don't know if you've ever looked at our Radioson data, but it looks like this. Let me 705, 29. So this is upper air data. And if we're constructing a 500 millibar chart, we would find the 500 millibar data right in here. So this shows that the height there is 5860 decameters. The temperature is minus 8.5, dew point depression 12, and our wind 300 at 23. And there's data for the 400 millibar level, 300, and so on. There's 300, there's 250. So that's what these programs do here. Okay, Jarrell. This might have been the 30th. I don't know. I'm going to take a look at chat. Okay, you guys said May 27th. Okay. So I'm going to bring in the May 27th data. All right, May 27th. Okay, we can see quite a bit of moisture there. Looks like dew points there around 23 Celsius. That's about 73 Fahrenheit. Very pretty good moisture depth, up to 900 millibars. So that's going to be up to about 3,000 feet. And let me switch this sounding around so the level goes a little bit higher. Okay, so you can see that there is some very good lapse rates in here, very steep lapse rates. And if we modify the sounding, that's kind of what we want to do there. I don't know of a really fast way of doing this, but I've warmed this up to about 92 degrees, which is, I think, close to what we saw for high temperatures. So that's kind of cool. You can do the stuff on Rayab. So let me enlarge this real quick. I'm having some trouble seeing what I'm doing here. Okay. All right, I'm having some trouble getting this all sorted out, but anyway, we can do this manually, all right? Okay, I hit the escape key. Rayab is kind of picky about the escape key, so... Okay, I messed that up. All right, sorry about that. Anyway, I can't get past this screen. Anyway, you get the idea. You saw how steep the lapse rates were on that sounding, so that's what a seriously unstable sounding looks like. We had, like I said, 5,000 Cape that day, and that was quite a bit there. All right, so let me get back to the forecast. I got pretty well off track here, and we'll take a look at the forecast. And the first change that we're going to see over the next few days is the return of the moisture back into the high plains. Okay, so there's the map we have right now for tomorrow's webcast. Tomorrow evening we see 70 or 60s making it up into Oklahoma and southeast Kansas. Deep southerly flow all the way to the northern plains, and we've probably got a stationary front in place here over Nebraska. Then advancing forward to Thursday, the infusion of moisture even further north up to Nebraska there, 60s dew points, all the way up to the Dakotas. Then for Friday, we see that all the way up to some of that moisture making it all the way up to North Dakota. Looks like we got our front entering the picture here. And yeah, we missed that. We can see that coming out of the Rockies right there on Thursday, coming across the northern plains on Friday. And then we get the tail end of that moving through Ohio and northern Missouri on Saturday night. So probably a good chance of some thunderstorms here Saturday night into Sunday. And likely with this front in place like that, we'll probably see afternoon thunderstorm activity along this region, maybe even nighttime MCSs from the weekend into Monday. And we see 70s just off the Texas coast there. And a little bit of upslope flow into West Texas. So we may have a little bit of dry line activity early next week. Next system comes through, similar track through the northern plains. We see the moisture coming north once again. So we're up to about the 19th and 20th. And here we see a pretty prominent low on Wednesday the 19th. Looks like active dry line through here. 70s dew points in northwest Oklahoma, so probably some traceable weather on this day here. And also possibly some severe weather up in Nebraska there with this front coming down. So around Thursday the 20th, kind of a similar picture. Cold front moving south, so this is probably going to be another chase day, Oklahoma and Texas. Then things shift southward around Friday. Looks like probably a boundary there across North Texas on the 21st. So it looks like we have quite a bit of frontal activity and boundaries. The upper level flow is probably set up over this region because you can see we've got cool air on its way southward, warm moist air to the south. So we've probably got a lot of ingredients in place around the 20th to probably about as early as the 16th or 17th through the 22nd. And then we've got high pressure filtering in after that. So we end up in a pattern kind of like what we have today. And then we get to the end of the run, so that's about all I got right there. So let me take a quick look at chat before I wrap things up. What am I using for drawing? I'm using a program called Zoom It. Not using a Epic pen. Fred and Carl, or Fred talking about the Rayab interactive module. Yeah, it's a great little tool there. And yes, it will be getting active finally, I guess, maybe as early as a couple of days from now. So we'll keep an eye on things, and we'll be doing the webcast again tomorrow night, 8 p.m., so hopefully we'll see you then. All right, thanks for joining, and have a good evening.